Hello, welcome back. Trigonometry, straight maths but enrichment. I was asked by a couple of people to do some harder questions on just trigonometry, so I have put aside maybe 3 or 4. I don't know in what order I will upload them and which one is going to come first, but this is the first one I'm recording. This is what it says. It says if the sec of x plus the tan of x is equal to 5/7, find the value of the cosec of x plus the cot of x. The question says more stuff in there. It says stuff such as without solving this particular equation as well. So no credit will be given for that. This is in one of my papers, the special kind of papers, and no calculator is allowed at all in the question. So you couldn't even solve it numerically and just get an answer. So this wouldn't have been an option anyway. So how do we proceed with a question like that? Just to discuss it very, very quickly. The combination of sec plus tan, or minus in fact, sec x minus tan x, or the other way around, doesn't really matter. The same way the cosec and the cot in just that cosec plus a cot or with a minus, no coefficients mind you, no ones, are very special. The sine and the cos are very upset because then they don't have that kind of setup. And I will explain what I want you to observe. If you look at the identity, 1 plus tan squared of theta is equal to the sec squared of theta, and correspondingly the 1 plus cot squared, which is equal to the cosec. These particular identities allow a difference of squares between the functions sec squared minus tan squared, which of course, now this will be a sec theta minus tan theta, and a sec of theta plus a tan of theta. These products are 1, so you can say sec theta minus tan theta is 1 over that, and vice versa. There's a lot of things you can actually do with this particular fact. It comes in all sorts of things, not just ordinary trigonometry. I've done it, I think I came across a very hard problem when I was doing my master's that had catenaries, like chains, that you had to manipulate hyperbolics. It was based on that. And the same thing if you have 1 plus cot, 1 plus cot squared is equal to the cosec squared. The same thing is true. Unfortunately, the better of all these 3 identities does not allow, of course, the same thing, because it's not a difference of squares there. Yes, there is a difference if we do 1 minus sine squared or 1 minus cos squared, but that's not good to have it like that. So once we are aware of this fact, okay, we can work as follows. We can say, okay, the sec of x plus the tan of x is given to be 5/7. Well, if I multiply both sides of this equation, and I'm going to put full workings for that, sec x plus tan x by sec x minus the tan of x. Of course, I need to do the same thing to the other side. Sec x, what am I timesing, but minus tan x. Then of course this is 1, so I can say 1 is equal to 5/7 sec x minus tan x, which consequently will say, when I divide it to the other side, the sec of x minus the tan of x, if that is true, is going to be 7/5. Why is that good? Because of course there's more consequences with this kind of patterns. Let me just leave the given and the derived. Well, I can add the 2 equations now because the tans will drop. So I can actually say, you know what, 2 lots of my sec of x, adding side by side, is equal to 5/7 plus 7/5. It's non-calculator. 25 plus 49 over 35. Quite an ugly number. 49, 54, 74. So this is now 74 over 35. That's the sec, 2 lots of that. So the sec of x is equal to a very beautiful number. Marriage material is in fact this one. The sec of x is 37 over 35, or if you like it, I can write it as a cos. We're happier. Still a very beautiful number. What is beautiful about it? When I was younger, I used to know a lot more of these beautiful numbers. I'm sure some of you know some of these beautiful numbers. The 3, 4, 5, and its multiples, of course. It could be 6, 8, 10. I don't count as a different one. The next one is 5, 12, 13. The next one, the 8, 15, 17. Then we got the 7, 24, 25. Then probably, it depends on which way you see the order ascending, is probably the 20, 21, 29. Then we have to go down, but this is now where this is coming, and that's why I said when I saw the 37 and the 35, very beautiful numbers, is the 12, 35, 37, and I think 9, 40, and 41 is another one, although this is now goes smaller. These are Pythagorean triples. I used to know maybe another couple. There's another one that has 53 now, I can't even remember, and one in the 60s. I don't remember anymore now. But that's good enough for what I want to do here. But even if you don't know this fact, we can still, the numbers are not that bad. We can still do this without a calculator. So now, does that imply I can just use a triangle? I'm not happy to just say at this line, many of us would, to say this is x, and the cos of x is 35 by 37, and of course this is a 12. Or I can do the Pythagoras, I can do the numbers, it's not that difficult, but that will imply that everything is acute or works in a right angle triangle. I'm not happy that both of these numbers are going to be positive numbers, so I need to do a little bit of a check. I know, for example, the cos is positive, and therefore the sec will be positive as well, but I don't know nothing about the tan and the cosec, because of course one could be positive, one negative, but the positive is bigger, and therefore it produces overall a positive. But we can actually check very, very quickly by using the same equations again. If I subtract them now and see what happens, I'm subtracting downwards as I'm seeing it. 2 tans of x, that minus that, is equal to 5/7 minus 7 over 5. Okay, so if this happens now, I'm going to get a negative number. So the tan of x in this particular case is going to be, it doesn't really matter what it is, I'm not going to work it out, it's of course less than 0. Okay, I have a problem now because I'm looking for something that has a negative, we have negative tan and positive, okay, and the cos of x is positive. Okay, what does that mean? It means in the quadrant diagram, all the silly tom cats, we are on the bottom left here. So when we're dealing with our numbers, the cosec of x down there will be negative, and of course the cot of x will also be negative. We have to be very careful with our workings for this particular question. I don't know if you're following what I'm actually saying. This just picks up the numbers, that's not the problem, but the cos of x is actually between, you can even think of this as negative angles between 0 and minus 90, or you can think of it between 270 and 360. It's the signs that are important. The triangle will still work. It will still give us, of course, the numerical values for the cosec and the cot and everything else. First of all, if you don't know these triples, it's not a problem to do a quick Pythagoras in there. Okay, 37 squared. 7 times 7 is of course 9, and we got 4, 3 times 21, 25, 3 times 7 is 1, 2, 11, and we're going to get 9, 1, 3, 1, 1, 3, 6, 9. That's the 37 squared. The 35 squared should be 1, 2, 2, 5, but we can just check it very quickly. 5, 25, 3 times 17, and then we got 3 lots of that, 15, 10, and we're going to get 5, 12, 1, 2, 2, 5. The difference between the two numbers, I hope they are 144, and 144 is not a difficult number. It does help, as I just explained a little bit earlier on, to know your Pythagorean triple. So for me, I wouldn't have bothered there to do any work. I know that's a 12. Okay, but it still can be done. The reason I'm showing you that, it can be done without a calculator. So we got that the cos of x is 35 over 37, and we got all the ratios in there. We after the cosec plus the cot. Let's ignore the signs at the moment, the pluses and the minuses. First of all, the cosec of x is the sign, but upside down. So the sign is here is 12 over 37, and therefore it'll be 37 over 12. But of course, the sign is down here now, it's an angle down there, and therefore it will have a minus. I didn't leave space for the minus. Let's move the equal a little bit. Okay, and what else we want? The cot. The cot of x, of course. The tan is 12 over 35. The cot will be 35 over 12. And again, the cot down here is negative, because the tan is negative, so that's in fact minus 35 over 12. Therefore, the answer to my problem, the cosec of x plus the cot of x, is the sum of those two. It's a negative number, of course. 37 plus 35 is actually turned out to be a nice number. Is minus 72 over 12, which of course is exactly -6. I hope you liked trigonometry enrichment. I hope you liked this particular question. Loads of different things to take into account by doing a question like this. Do not panic, it will not come up in any standard exam. Only in my papers you'll find questions like this. I will see you very soon. Who's laughing now?